Okay, good afternoon, welcome back again. We have in this chapter, we are going to talk about graph and 10.2. We see that the graph was introduced by the Euler that have seven, I think, a countryside and some bridges, and there was a question about how to connect between them. Is there any path to visit all of them without repetition or not? Is the direction or an indirect? That's all what we have. I think we have before we had some type of the graph. We changed it to the matrix, if you remember. So in this section, we are going to talk about the quality and quantity of them, which type we have, I mean by quality, and what do you mean by the matrix of them. Generally, we have a loop, you saw that one before, and we have an edge. We have an edge, right? For example, I have some points like A, B, C, D till edge, till G, and this is called what? That one is called what? How about that one is called? What's the difference between that one and that one and that one? You know, in the G, there is no relation, right? There is no edge. This is called edge, this is called vertex. So C and A, and all of them, A, B, C till D, E, are what? Are vertices. And this line is called edge. And this circle is called loop. Okay. Now, each of them, if you have a property, if they have a, for example, there is no connection, it's called isolated. If there's a one connection, it's called something. If we have two or more, we call something else. So you can see from here, isolated is what? Pendant is what? Pendant is if you have each vertex or one vertex just has only one edge, for example, like that. So you know that one's AB. So B is what? Is pendant. And if I have a C, C is isolated. There is no relation. Maybe during the exam I say what we call C as what? Like that. So do not forget about the name. And also we have many things here, but I'm going just to mention what's the important things. In undirected, what do you mean by undirected? We have A and B, C. Maybe there's a relation between them. If we put something we have like that, means that they are direct, and we have nothing is undirected. Okay, undirected graph. So generally, if I have a vertex, or I have a vertex with the edge, or we have a vertex with many edges, called graph. Okay. Now, what's the number of here? What's this theorem? The theorem is talking about the handshaking. You know, when you are shaking the hands, how many hands do we have? For example, we have one hand, but we have multiplied by 2, right? Because 2 hands make this shake. So that's why the 2m is equal to the degree of vertex. What's the degree, Jama'at? Degree, for example, I say degree of here. The degree of, in this example, degree of A, is equal to 2. Means that he has 2 edges. Degree of B is equal to what? 4. How about G? 0. Now, you see what? We have in the undirected graph with M edges. M edges. What do you mean M edges? Means that 1, 2, 3. I have a 3 edges. So you see what? We have a 2m is equal to the 2m is equal to what? To the degree of V. Generally, what do you mean by that? For example, I have what? Right? How about summation of degrees equal to what? Summation of the degree. Degree of A is equal to what? 2. Degree of B equal to what? Degree of C equal to what? How about D? The summation of them is equal to what? 6, right? So the summation of the degree is equal to 6. Am I right? We say what? We say we have 2m. Was m equal to what? 3. Means that the real number of the edge is 3. And this is a small example. You can control it by, how about if I have a network, like your network? So you can see this, that's why the cryptography is there's a relation between net and math, networking and something like that. So think about, you have a source here and you gave the net to the other subsource and you change that onto a lot. If you try to count the line, how we count them? You see how many lines do you have? For example, see I have a 3 line. You see you have a, for like IQ. Have a question? Yes?
No, that means.
It's the degree, dears. We say that. Look. Just look. My picture, it was my graph, it was like that. A, B, C, D, right? We say degree of A equal to 2. How? Because it has got 2 edges. The degree is that like that. Do you remember that we say degree of G is 0, degree of A, degree of B is equal to 1, 2, 3, 4, degree of A is equal to 1, 2. So tell me about degree of, for example, A. Now I say 1, 2, 3, 4. You got it. And the theorems, handshake theorems, say what? Say that if you add all degrees, add them. So how we add all degrees? I say degree of C, 1. Degree of B, 2. Degree of A, 2. Degree of D, 6. Right? We got 6. The sum of degrees, 6. He say what? He say M, number of edge, equal to summation of degree. So I say 2M equal to what? 6. So M equal to 3. What do you mean by 3? Means that you have 3 edges in the total graph. Why we count double? Because it's like handshaking, is shaking as we say. You got the idea? Good. So this example is important and think about it at home. We say what? We have a 10 vertices. Means that A, B, C, D, E, F, G, H, I, J, K. Right? Like that? 10 vertices. Okay. And each vertex has got 6 edge. Degree 6. Sorry, not 6 edge. Degree 6 means that A, 1, 2, 3, 4, 5, 6. B, 1, 2, like that. So he asks you, how many edges do we have total? 60 divided by 2, right? Understood? You got it? Each vertex multiply by 10 degree. Okay. Now, how many lines do we have? We are going to 60 divided by 2, you will get 30. Understood? Good, that's it. This theorem is not our problem. Forget about it. And the definition is what's the initial, what's the adjacent from U. So it means that we have a UV, they are close to each other. Let me go to the important things. How about in the directed graph, we have an indirect and undirected and directed graph. In the undirected graph, it's okay, the degree you can count is easy. But for here, we have 2 types of degree. In degree and out degree. In degrees means that what? How many degrees come to you, come from you. So, for example, A, for example, B. How many degree we have? For example, in this C, how many we have? Look at here. You can see the definition first. We have in degree a vertex denoted by G in minus. Okay, is the number of the edge with the V as their terminal verse. Terminal. Last one. So it's the in. That one is in, and that one is in. You know, the initial and terminal. Initial, terminal. You are going to Kirkuk. Your start point is called initial point. Kirkuk is what? Terminal point. Now terminal Sharazu. So it means that you are going from the Sharazu till here is the final decision, final location, destination, right? So this is the terminal. Now you can see degree of B is equal to what? 2. What do you mean by minus? Comes to in B. Okay, how about degree of plus out is the initial. So how many initial we have? For example, for C, look, 1, 2, right? You got it? Tamam. How about degree of in of C? Let me check. How many we have? 3. So loop, yeah, that's why I mentioned C. 1, right? This is the in. That one is in. How about here? In also. So at the same time, loop is what? In and out. You can count twice. Okay? If you are not here, you lose some mark. You got it? Good. So this is the, summation of in and summation of out will give you the total number. During the exam, maybe I ask you to give me a complete graph for 4. Careful, Kaka. Or I will give you the graph, I say call them or write them or fill the gap. This graph is called what? It's called K4. What do you mean by K4? Means that complete. What's the complete? There's the complete. Each vertex by Kn means that K1, K2, K4 is a simple graph, means that there is no loop. There is no loop in it, simple graph. Exactly one edge between there of distinct vertex. If I have 2 points, I have exactly one. If I have 3 points, one between here, one between there. If I have 4 points, one here, one there, one there, one there. And between these two and between that two. So this is called complete. Understood, dears? So if I have, for example, K10, how many edges did the other vertex have? 9, exactly. Because each vertex will be connected to the other. It's like a net, you can imagine. Understood, Kaga? Tamam? Good. Did you understand anything? Okay. You understand? Good. So here's the K1. K1 is also complete. Because the definitions say what? Look, between 2, we have 1. How about if you don't have 2? We don't have a 1. So it means that they by negation of the definition, they satisfy. So K1 is 1 point, K2 is just line, K3 is triangle, K4 is the box with the complete edges. Good. What's the cycle? Yeah, that one. It's not complete. If you want to complete this one, should be also connected to that one. Understood? If you want to make that one complete, that one also should have 3, 1, 2, 3, because I have 4 vertices. So I should have 3, 1. I asked the other students, I said, if you have 10 vertices, how many edges for every vertex do you have? 9, right? 9. So yes, we have an incomplete, we have a complete. Okay. How about cycle? Means that there is a close. Means that we have an initial and terminal. They are the same, like that. Understood, dears? How we call that one? You say C2. Do we have a C2? No, there's no complete. There's no closed. We have a closed area. So you have a C6. Did you get a cycle? So KC. Each one has got property. Now, wheels is the cyclic, okay, but we put one edge, we add, I think, the additional vertex to the cycle. I'll let the additional, I mean that put one edge, sorry, you know what end, one vertex in the middle. For example, I have that one, I'm going to put one here. How about for the C4? We have a point here. So it's called W3, W4, W5, W6. Did you understand that one also? Hello? So it's the type of the vertices. I'm a typing. So I have a K, I have a W, I have a C, right? Good. And that's the cube. We don't need. It's okay. Forget about that. Forget about that one. Bipartite graph. What do you mean by part? Yalla. Let's translate. What do you mean by part? Yalla. Yalla. Class participation. Somebody say, why I got 2? Why? What's the meaning by part, Kaka? Part, partition. By part, 2 partitions. 2 partitions. So, what do you mean by that? Look at the graph. It means that you can make the 2 groups. 2 groups. Just look at the example. You don't need to follow the definition or theorem. Just look at the example. Look, Kaka. Now you understand. Where's the group? Here's the group, right? Here's the second group. Understood? Or you can make it like that. So now after the graph, I'm going to... No, this is not. This is not like that. It should be the definition of it. Look at the definition. Simple graph is called by parts. If there can be partition into 2 disjoint set V1 and V2, that every the graph connect to the vertex in the V1, connects a vertex in the V1 and a vertex in V2, so there is no as connect the 2 vertices in the V1. 2 of the points shouldn't have the relation here. Sure. Yes. Now A and B, did they connect? Direct connect? No. How about B and C? So B and C cannot be in the group. How about G? Cannot. How about Fi? Let me see. If I bring D2 up. G and F. How about D2 up, right? So also I can bring D2 up. Am I right? Hello? Because there is no connection between D and A and B. How about E? No. How about F? No. You know what I mean? Here's the vertex here. They shouldn't reconnect. So now I have A and B and D. To check me, I am right or not. Just look, Kaka. Just look. Is there a relation between A and B? No. So I'm going to put A here. Is there a relation between B and D or A and D? Direct, I mean. No. So I'm going to put D also here. Now I'm going to check C. C can be here? No. You have a relation with B. G? No. F? No. E? Of course, no. Tamam. So A, B, D, right? That's it. Did you understand what I do? Good. So my group will be like that and the other will be like that. Look, G. Is G connected with F? No. F connected with E direct? Well, I don't know because I wrote everything. Now, let me check again. With E, do we have? No. So E also here. D, of course, no. C. Let me check C. C, yes. Understood? So we can make the group 1, group 2. A, can we connect to E, C, G, F. How about B? B can connect with C. Change color key. Change color key. يلا فرمدي. C, B. Yeah. B with C with E, F. You are right. E and F. How about A? D. 1, 2, 3, 4. So D with C. Understood? Kaka? Did you understand? We can make that by partition. How is the definition? The elements shouldn't be related to each other, shouldn't be connected to each other, like that. So during the exam, maybe I'll give you the set like that. I say, is that by partitions graph or not? You say yes, you say no. You say yes because you make it, no because you have all relations. Understood? Can you make that one 2 by parts, K4? Huh? No, right? We cannot do it. Understood? Can you make that one? Think about it. C4? Are you sure? How? Make it, Dayala. Make it for me. Think I'll make it. A, B, C, D. Think about it. Can you make it? Make it. Don't tell me. Make that one. And C. Maybe. Maybe. Why? Maybe. Maybe not. Do it. Understood? Can we do W4? Right? So it depends on the example. Here's the by. Look. It's called K23. What's a K23? It's a special type of by. Why is a special type? Why is it called K23? Yeah. At the beginning, this is complete. What was the complete? Because each vertex, they connect, right? But how about here? No. If I have a V1, V2, V3, V4, V5. But V1 and V2, they are connected? No. But because we make the two groups, and the first group is connected to the other, and the second group is connected to the others, so we can recall them as a complete, but by complete. Means that we have a partition, because they are not connected. We have another partition, G2, G1 group, first group, second group, but G1 with G2 is complete, right? And G2, the first vertex, and the second vertex also is complete. How about that one? It's K33. K33. So 2 is the number of the vertices, okay, and the other one. How about that one? K35, K55, I don't know. So kindly study these examples, not the exercises. You know what I mean? Kindly study these examples, not the exercises. Because this means that if you can't control that one, the same things happen for here. Look. Okay? Maybe for the outer and inner, these ones are important. You can check. Did you understand? Do you have any question? Easy? Good.